We present MMOR, a large multimodal operating room dataset for semantic understanding of high-intensity surgical environments. Surgeries are very complex, and even today it's very difficult for a computer system to truly understand what's going on in an operating room. And actually, real surgeries are coming in multiple varieties, and the complexity is actually quite intense. And of course, the what's on the line is also quite high. The motivation for our work is that because the operating rooms are both high stakes and complex, involving many actors and tools and equipment and all interacting in real-time constraints, we need what we call holistic operating room understanding for intelligent assistance for the future of the surgical procedures. By holistic operating room understanding or modeling, we mean using every signal input modality that's available in the operating room for decision support, for context-aware intelligence, and ultimately, of course, towards semi-automated surgeries. We believe holistic operating room modeling cannot be achieved through vision alone, and we need to actually consider all the possible information that is available in the OR for an accurate, versatile, and robust modeling. This, however, requires high level of integration and manual data collection efforts in the operating room, where the previous data sets are simply lacking in their size, realism, or multimodality. To this end, we present MMOR. A large-scale operating room dataset consists of multiple modalities and angles, such as multi-view RGBD video, a point cloud, additional detailed RGB videos, the screen recording of the robot, sound, and finally we also have segmentation annotations and scene graph annotations, as well as downstream annotations. Here is a short teaser video showcasing how our dataset looks like. Overall, MMOR is made out of realistic, total and partial knee replacement surgeries with real surgeons. MMOR consists of 17 full-length, around 90-minute video recordings, as well as 22 additional shorter clips, totaling 90,000 unique time points. In this video, you can see some examples of the angles that we have recorded from, the point cloud, the detailed views, as well as the multimodality aspect, where you see the robot screen here visualized, or the tracker information visualized here. We have 3D segmentations, as you can see here, as well as 2D segmentations from 3 angles. As well as I mentioned before, scene graph annotations, connecting every entity with each other through relationships. To go along with our dataset, we also devised a new method, the first multimodal semantic scene graph generation method. It uses modality-specific encoders to process individual modalities such as RGBD video, robot screen, point cloud, audio, robot metadata, tracking data. We bring them all together into a shared token space, and we use language modeling for semantic scene graph generation, meaning our model predicts subject, object, predicate triplets. We do a staircase ablation study where we keep adding one modality after another and show generally that more modalities improve the overall results. Here we have some examples for segmentation predictions of our baseline model, as well as some scene graph generation results. The scene graphs, as you can see, correctly capture the semantics in the scene, such as the head surgeon sewing the patient, holding a saw, manipulating the robot, the patient lying on an operating table, and so on. In conclusion, we have presented a new large-scale operating room dataset and a new method to go along with it. Both our code and dataset are already open source, and we believe this will enable the community to work on many exciting problems.